So looking at this question related to WSPS model, in the first part we looked at how can we write our WS and PS equation with system. This are WS and PS equation in terms of their weight wage. Then in the second and third part, we plotted them first against and then against. And in the fourth part, we finally solved for equilibrium unemployment rate, real wage and output. Now in the last part, we wrote that a new law that increases unemployment benefits is passed, which results in increase. So the keyword here is that Z goes up. What will be the direction of the sexual equilibrium real wage on unemployment? Right, so we want to see what happens if Z increases to the equilibrium values of unemployment, real wage, and output. Right, so now when we want to do part D, so now since we've already algebraically derived the equilibrium values for Y and UN and the equilibrium rate wage, we can either use these equilibrium values or we can do it graphically, right? Because the question is asking us for the direction of change. So we can either do this algebraically or graphically. Let's see how we can run it in both ways. So now using equilibrium values, we derived in part D. So let's use the equilibrium values we derived in the part. So in part D, let's just zoom in a bit. So if we look at this, in part D, we found this as UN, right? So this is the value of UN. So this is the value of UN, 1 minus Z by 1 plus N, right? So this is the value of UN, this is the plus N. Right, so we use this value that we know that UN is 1 minus 1 by Z1 plus. Now I want to see what happens here as Z increases, right? That's what you want to see, what happens here as Z increases, right? So now as Z increases, right? So Z increases, that causes 1 by Z1 plus M to go down because we know Z is in the denominator. So when the denominator of a fraction increases, overall fraction goes down. So now what you're doing is you're subtracting from 1 a smaller number. So 1 by Z1 plus N, this entire thing decreases, right? And this is essentially UN, right? So what you're seeing is UN goes down. So as Z increases, UN goes down. Why? Because when Z increases, 1 by Z1 plus M goes down because it's in the denominator. And from the denominator, you're subtracting a sorry, because see, when Z increases, 1 by Z1 plus M goes down because Z is in the denominator, and for denominator, as the fraction increases, the fraction value goes down. And now from 1, you're subtracting a smaller number, right? So this has essentially gone down here, this is gone up here, right? So from 1, you're subtracting a smaller number, so overall this fraction increases, sorry, my bad, not decreases, this increases. Sorry, this increases. Sorry, so UN goes up, right? So this entire thing increases, right? Because see, when Z increases, so over here you have this fraction. What's going to happen is when the denominator increases, the overall value of the fraction decreases. From 1, you're subtracting a smaller number than before. So this value overall increases. So UN essentially increases here, doesn't decrease. Right, so this is one way to look at it using the equilibrium values we derived. Alternatively, we could have seen what is partial UN by partial Z. So this is, if you want to take the derivative of this, so in that case, it is helpful to first to rewrite it in a form like this. Let's write it to take the derivative. It would be helpful to write, let's just write it. So let's just write it over here, or we know UN, we can rewrite it in a form which is helpful to take a derivative with Z in the numerator, right? 1 by now, when I take the derivative of this with respect to Z, so we know the power is going to come down. We're going to reduce the power by 1. So the derivative of this becomes 1 by 1 plus m z square. And this is positive because we know z square is always positive. It equals square term here. And m, the markup is also positive. So this turns out to be positive. Now, how do we interpret this? Now, for this, we need to understand how do we interpret partial un by partial z. Now, partial un by partial z is basically changing un as z changes. Because remember, dy by dx is change in y as x changes. So this is change in un as z changes. So if this is positive, because see, we're only interested in the direction. We're only interested in the direction. So this is positive. This tells us un changes in. So this is telling us the change in un is in the same direction as change in z. Right? It tells us un changes in same direction as z. So this means that if, let's just go down a little, if z increases, un increases. Similarly, if z decreases, un decreases. Right? So here we basically found partial un by partial z. This is change in un as z changes. Remember, dy by dx is change in y as x changes. Right? So this is positive. This means that un changes in the same direction as z. So if z increases, un increases. If z decreases, un decreases, right? So basically, when it's positive, it's just telling us that un changes in the same direction as z. That's how we interpret the positive sign. So partial or partial z is positive. So as z increases, un increases, right? If z had decreased, then un would decrease, right? Right. So this is about un. Now we're seeing the factor un. Now let's do the same. So algebraically, we looked at the value of un. You can either just directly from here, from the equilibrium value, see that when z increases, 1 by z, 1 plus m goes down. So 1 minus 1 by z, 1 plus m goes up because from 1 you're subtracting a smaller number. Or you can look at the derivative and show that the partial derivative of un with respect to z is positive, which means that un changes in the same direction as z. So if z increases, un increases. If z had decreased, un had similarly decreased. The positive sign just simply means that un is changing in the same direction as z. Because remember what partial un by partial z is. It means change in un due to change in z. So now let's go back and let's see what happens to the equilibrium real wage. For this, let's see the value that we derived. For the equilibrium real wage, the value we found was this, which we said was given by the horizontal um, PS curve, which we said was given by the horizontal PS curve. So this was the value for the equilibrium real wage 1 by 1 plus n. Right, so if we go back 1 by 1 plus n, so equilibrium real wage is 1 by 1 plus m. So this is unchanged as unchanged, right? So this is unchanged as z increases. So as z increases, it is unchanged, right? Does not depend upon z. Does not depend. It does not even depend on z. We know in this case it's given by the right. We know it's given by the horizontal PS curve. Right? It does not depend upon z here. It's given by the horizontal PS curve. Right. Equilibrium real wage does not depend upon z here. So this we've seen. So now let's look at what happens to the natural level of output yn. So if we go back and we'll see how we found yn over here. Oh, sorry. So this is why the value yn that we found here, L by z1 plus m, right? So now let's see what happens to this. Now here again, you need to see what happens as z increases. So as z increases, we know L by z 1 plus m goes down. Because see, when the denominator of a fraction increases, the fraction goes down in value, right? So this means that as z increases, yn decreases. Or we can again compute the derivative. So for this, let me rewrite yn with z in the numerator. But it's helpful to take whatever you take in the derivative of the numerator. So I'll write it as z minus. Now I'll do partial yn by partial z. So we'll take the power down, reduce the power by 1, and then we can rewrite it like this. Minus L by z squared 1 plus. Here we know the markup is positive. Labor force is obviously a positive value as well. So overall this derivative is less than 0. And remember, what does partial yn by partial z tell us? Partial yn by partial z tells us change in yn as z changes, right? So if partial yn by partial z is less than 0, z changes in opposite direction to yn, right? This is telling us z is changing. The sign is telling us that z is changing in the opposite direction of yn. Okay, if sorry, tells us sorry. So not z changes, y changes in opposite direction to z by that. Right, so partial y by partial z is the change in y and z changes. So if this is negative, the sign is telling us that y changes in the opposite direction to z. If z increases, y will decrease, right? And similarly, if z decreases, yn will increase, right? That's what it is. Just remember, the sign of your derivative tells us that in which direction will if we are dy by dx, sign of that tells us in which direction y changes, x changes. If it's positive, y changes in the same direction as x. If it's negative, y changes in the opposite direction. So in this case, it's partial y by partial z less than 0. So as z increases, y decreases, right? So just keep in mind, whenever you find dy by dx, it's changed in y as x changes. If the sign is positive, this means the y changes in the same direction as x. So if x increases, y increases. If x decreases, y decreases. If it's negative, this means that y changes in the opposite direction as x. So if x increases, y decreases. If x decreases, y increases. So either way we've shown. So now in this way, using the algebraic values, we've shown that what happens to un, yn, and equilibrium real phase as it changes. Now let's show this graphically. So instead of doing this algebraically, we could have done this graphically. So for graphically, so let me just quickly make a graph here. Right, so this is our horizontal price setting. Yeah, so now it's fine. So this is our graph, right? So the vertical axis we have the wage, on the horizontal axis we have Q. This is our WS, and this is our PS, and this is our equilibrium. We know it's horizontal. This was our initial equilibrium A, where equilibrium real wage is 1 by 1%, and this was U. Now graphically what happens is, let's say initial equilibrium is at A, where WS and PS intersect, and equilibrium real wage is 1 by 1%, and in the equilibrium unemployment rate is U. Now what happens is, as Z increases, we know that causes WS to shift upwards. Because we know when Z increases, that results in an increase, because an increase, so when Z increases, due to an increase in unemployment benefits, so that means the workers have more bargaining power for any given level of unemployment rate, so they demand higher wages for any given level of U, so the WS curve will shift upwards, right? So we know that the WS curve is now going to shift upwards. Right. Yeah. Now we know when Z increases due to an increase in unemployment benefits, so we know workers have more bargaining power now. So for any given level of use, so they can demand higher wages for any given level of use. Thus, the WS curve is going to shift upwards. Right? We know changes in Z affect the WS curve. Right? So let's just look at this, and yeah. So this was WS, and this is WS prime. So this increases, right? Now the new equilibrium is going to be given as, so new equilibrium is at A prime, where the new WS curve and the unchanged PS curve intersect. So this is new equilibrium A prime. Here we can see the UN increases and equilibrium real wages unchanged. Let's just show it on the graph also. And equilibrium real wage is unchanged. Right, so let's show, so here we can see this is UN prime. So we can see UN increases, and you can see equilibrium real wage still at 1/1 plus, right? So in this way, graphically, we can also show this. Initial equilibrium was at A, and then then Z increased, which caused WS curve to shift upwards. The new equilibrium was at A prime, where UN increased, and equilibrium railway still at 1/1 plus. Now, using the WSPS diagram, now using WSPS diagram, graphically, we can't see impact on equilibrium. Why? Because here we can just see the impact on equilibrium, unemployment rate, and real wage. We cannot see impact on buy-in, but we know when UN increases for a given labor force. So for a given labor force, what's going to happen is NN is going to go down. Equilibrium unemployment rate goes up. For a given labor force, NN goes down. So as a result, YN goes down. Right? YN goes down. Because we know when UN increases for a given labor force, the natural level of employment is going to go down. So the potential level of output is going to go down, because it positively depends upon your level of employment. Right? So in this way, we can see when Z changes, how can we algebraically and graphically see the impact? For algebraically, we just look at the equilibrium values we derived, and graphically, we just draw a WSP chart.